So I will start with the uncertainties, the part we have in our paper dedicated to this point. This is the layout of the document. So there are a complete document dedicated to uncertainties on the derived value written by the C3 group. But here we focus on the uncertainty on the ground model, and so we will just evocate this point. The main point I will discuss in this presentation is how to assemble the ground model and the uncertainty we can create or have during this task, some aspect on the computerized interpretation, and how to validate the ground model and represent the uncertainties, because this is point that have not been covered by the Eurocode, but and is still unstandardized for geotechnical aspect. So there are a lot of source of uncertainty that we can have, and when we create the ground model. So they are listed here, and I will go through main of this point in my presentation. So there is the geological complexity. So sometimes there is the very site with very complex history, or geomorphology is very difficult to understand in the first just in the first round. So we must have this iterative aspect of the project. There is the problem of sometimes the personnel or the experts, so that is probably not from this region or have not the good information. The data, the accuracy of the data we have gathered in our project or is given in the project. And also sometimes there is a problem of resource that we have in this project. So I probably won't cover this, but mainly the other. And this gives us some uncertainties in the way we build and we create, and the precision or uncertainties we have on the surface or the border of the ground geotechnical units. So there are some aspects that we all know, is that what we want is to define the layering, and so the difference between the different units based on tests we have. So it depends on the region. We have sometimes we are more CPT or more SPT or more pressure meter. Whatever is the fact is that we try to look in the signal, and I will detail it after, but we want to create the different zone, and sometimes we have difficulty because when these tools goes in a transition zone, they have a variation in the parameters we get, and so even with the best tool or even the expert, it's not so easy to define where the layer change or what is the thickness of the interpenetrate layers. And so this gives us what we want after is the model, and so trying to have homogeneous zone to go to the design. And just a small example. Here we have done 29 CPT in a very small zone in a very short period of time in a spring, and so it gives us the variation we have in a very narrow zone, and so we can use the tools that are defined and detailed in the C3 guideline, but it gives us an idea of the difficulties for the engineer to, even with the best tool, to define the layering of this specific zone in a slope. So there is an important thing that we do each time when we do a design, is that usually it takes the same drawing than Matthew have shown before, where we have the zone of influence of our building or our project, and so we sometimes put the investigation in the surface of the building, and but some outside, and the first thing that we will probably want to do is to try to make like a cross section, and this cross section we have several strategies to do it. We can have a strategy that is probably the best, the more reliable, is to use only the point we know, So we have no uncertainty on this point, but we don't have information between or out of this zone. The more optimistic engineer will try to just put the line here because it's the line of its project here or this foundation, and he will have a lot of uncertainties because he will try to interpret or to extrapolate the data he have on this sounding, and to try to have all the zone of influence without any more sounding. So I think it's a very important way of having building or constructing the ground model and trying to know where are the uncertainties and where we create uncertainties in gathering the data we have for the project. Because at the end we want to have these geotechnical units, and we want to put data or value of the parameters in these units and to go to the design stage. So this is a very important aspect, and so the idea is how can we manage this and how we can represent this, because if we are a company that do this stage, we want to go and communicate. So it was the point in ACAN slides. So we have a tool for communication, so we need to give this drawing to another company that probably will design the pile or check the pile. And so it's very important to check and represent these uncertainties. So just some aspect we cover in the paper. So the example of some uncertainties, sometime between the sounding, we have all the information, so it's okay. There is a variation of thickness, so we deduce that there is a variation of the thickness, but sometimes there is a layer that is not present here in one side, but on the other side. So we need to make some assumption or decide what is the risk to change this or make another sounding. So it's a way for this train running and making different project, evolving the project. There are also the importance of the geology. In some part, we will have some aspect that is probably not always seen by all the engineers, probably not so aware of this. So there's some aspect here that I won't describe in detail, but you will find. So there are some information you need to have that is from your culture or your education that you need to use for this. So it's also part of the human aspect of the uncertainty in the ground model. And there are also a very important point. It's also the problem of the resource. If we have a lot of money and we want to have a very detailed exploration, we just have to have a systematic exploration of our model, but it's not probably it's not the case for 99% of the project. So usually we have a more empiric strategy. So we have what we have in the previous slide, our project, and we just place the sounding at the place that the information in the bibliography or the geology seems to prove that to be of more interest. And so this is the main point. And after you have to have a pre-treatment of all this information to go in the software. And sometimes there are also uncertainties at this stage where we make this choice not only in 2D but also in 3D. So it's quite a complex task for the engineer. So after, when we go to the process of creating, we can do it by before by hand or drawing. You can take a pen and draw. It's like Matthew present verbal or schematic. But nowadays we have much more tools that we use that go until the machine learning aspect. But all this will have the idea. So it's evolved in the 3 decades before. So it's different tools to create this surface or this border with a different aspect of uncertainty, taking account these uncertainties to create the place where we see that there is the best probability to have the layer or the difference, the border between the ground units. And so this is still a train running, but not the same train exactly, but it's another way of where we gather information and try to improve and reduce this using this type of tool. And after we have created all this model and we try to validate it, because we need to have like a check of all these points. We have several tools in geotechnical engineering and geological engineering. It's that we have principles, so it's the law, well, it's like laws we have, and so we need to make a checksum of this, all these points, in fact. So there are, I won't read all these lines because I think it's in the paper, so it will be freely, it can be freely downloaded in few months, I think, but or weeks. But the point is that this need to be known by everybody. It's not just a young engineer that go out of the and came for a project and we give him to define the model. You need to give him this key, in fact. And so there are the principle of geology, the existing site model. So all the history, all the information we have around the project or the zone of influence. You have always information. And so now with the cloud-based database, we can have more information and share information about the sounding in all over the cities around our project. So it's very interesting to have this information to see the main key point that has been taken in this project, and that all this also simple logical aspect of the geomorphology. And at the end, so it's probably the one point that is very open for the future is that how to represent these uncertainties. So there are national habits or national guidelines. For example, on the left-hand side, it's a guideline from Finland that has been taken. And so you can have in this guideline some ideas of how to represent by colors or by a grayscale or by letters, how the uncertainties of the borders of the model is proposed. But you have also this type of tool that is published and available, and that make that it's also you can make the comparison with the drawing of Akan, where you improve going from the initial to the completed or verified model, where you can place some uncertainties. The very simplest things is to put I have the word in French, but so this question mark. And you can also have grayscale, or you can try to present. And so all these tools are almost standardized for the 3D software. But for the moment, we don't have put on the paper, but it's what we try in the paper. But previously, it does not exist. How do we need to represent these uncertainties in the ground model? So there are some guidelines in our paper for this, and so I think it needs to be used to have a better communication between the different partners of the ground model.